Copper is a mineral and an element which is essential to our everyday lives. It is a major industrial metal because of its high malleability, thermal and electrical conductivity, and resistance to corrosion. It ranks third after iron and aluminum in terms of quantities consumed in the USA. Copper is easily alloyed with other metals. Brasses and bronzes are probably the most well-known families of copper-based alloys. Copper pipe for the plumbing, heating, and air conditioning industries is available in drawn and annealed tempers, and in a wide range of diameters and wall thicknesses. Temper describes the strength and hardness of the tube. In the trades, drawn temper tube is often referred to as hard drawn, and annealed as soft copper tube. Hard drawn pipe comes in lengths, and soft copper tube comes in rolls. Hard drawn copper shouldn't be bent. Soft copper tube can be bent. Copper tube for air conditioning and refrigeration, also known as ACR, is designated by actual outside diameter. Copper tubing for plumbing and heating applications is designated by the inside diameter. Except for this difference between ACR and plumbing and heating pipes, the type only indicates wall thickness and does not affect the outside diameter of the tube. Type K ½ inch, type L ½ inch, and 5/8 inch ACR all have the same outside diameter of 5/8 inch. Types K, L, M, ACR, and DWV must be marked to show pipe type. Hard-drawn pipe will have this information printed on it in a color which distinguishes its pipe type. If you look at the picture on the right, you will notice type K has the thickest wall section of the three types of pipe and is commonly used for deep underground burial, such as under sidewalks and streets. It has a suitable corrosion protection as required by code. It has green colored printing. Type L has a thinner pipe wall and is used in residential and commercial water supply applications. It has blue colored printing. Type M has an even thinner pipe wall and is sometimes used in residential and commercial water supply, but mainly it is used in heating applications. It has red colored printing. Type DWV, which is not in the picture, has the thinnest wall section of all and is generally only suitable for unpressurized applications, such as drains, waste, and vent lines, hence DWV pipe. It has yellow or light orange colored printing. The use of DWV pipe has largely been replaced with the use of PVC. ACR is type L tubing that has been cleaned or manufactured without oils and is charged with nitrogen and the ends of the tube sealed to keep the nitrogen inside. It has blue colored printing, but ACR is included in the printing on the pipe. As you can see in the picture, only type L and type K comes in either hard-drawn lengths or in rolls of soft copper tubing. When ordering copper tubing, you need to tell the supply house the type you want, the length you want. Hard-drawn pipe comes in 10-foot and 20-foot lengths. Soft copper tubing comes in rolls from 20-foot up to 100-foot. As an example, you want to order 5 20-foot lengths of 5/8 inch ACR and 5 20-foot lengths of ½ inch type M. You would tell the person how many and the length of pipe, the size, and then the type. So you would tell the person at the supply house, I need 5 20-foot lengths of 5/8 inch ACR and 5 20-foot lengths of ½ inch type M copper pipe. Hard-drawn copper pipe is usually joined by soldering or brazing with fittings. Soft copper tubing can be joined by the same techniques. It is also possible on soft copper tubing to expand the end of one tube so that it can be joined to another by soldering or brazing without a fitting, a procedure that can be efficient and economical in many installations and is known as swedging. Soldered joints with fittings are used in plumbing for water lines and for sanitary drainage. and heating for the supply and return lines to the terminal unit and for the potable water connections. Braze joints with fittings are used where greater joint strength is required or where service temperatures are as high as 350 degrees Fahrenheit. Brazing is preferred and often required for joints in air conditioning and refrigeration piping. The basic difference between soldering and brazing is the temperature necessary to melt the filler metal. That temperature is defined to be 842 degrees Fahrenheit by the American Welding Society, but is often rounded to 840 degrees Fahrenheit. If the filler metal melts below 840 degrees Fahrenheit, the process being performed is soldering. Above that temperature, the process is brazing. The melting point of copper is 1,984 degrees Fahrenheit. As such, the filler metals for soldering and brazing copper and copper fittings must have melting temperatures below this temperature. Soldered joints depend on capillary action, drawing free-flowing molten solder into the gap between the fitting and the tube. Flux acts as a wetting agent and when properly applied permits uniform spreading of the molten solder over the surfaces to be joined. What do we mean by capillary action? To put it in very simple terms, it is the ability of a liquid to rise into a narrow gap or passage against the force of gravity. The primary element used in solder filler metals is tin, because tin has an affinity for copper and wants to adhere to the copper tube and fitting. However, the use of pure tin would make a very weak joint. As with any pure metal, it would be difficult to work with. Therefore, other elements are added to alloy with the tin to provide strength and make the filler metal easier to use. 95-5 solder wire, which is a lead-free alloy of 95% tin and 5% antimony, and has a 450 to 460 degree Fahrenheit melting range, is a common solder used in the field. Braze joints are generally used to achieve higher joint strength. To accomplish this, filler metals stronger than those composed primarily of tin must be used. However, this increased strength generally comes from filler metals made of materials that melt at higher temperatures. The brazing temperatures for most of the brazing alloys used to join copper pipe is between 1,150 degrees and 1,550 degrees Fahrenheit. The most commonly used brazing filler metal types used to join copper pipe and fittings fall into two distinct categories. B-cup alloy, where B stands for brazing, Cu is the chemical symbol for copper, and P is the chemical symbol for phosphorus. Therefore, a B-cup brazing alloy is primarily a copper-phosphorus brazing alloy that may contain from 0% to 30% silver. Bag alloy, where the B stands for brazing and Ag is the chemical symbol for silver. While there are other elements found in bag alloys besides silver, the majority of bag alloys may contain silver content of anywhere between 24% and 93%. No matter if you are soldering or brazing, you want to do it properly. The picture on the upper left shows a good joint and a joint that does not have solder. The picture on the upper right shows you a good joint and a joint that has too much solder. The picture on the lower left is of a properly brazed joint. The picture on the lower right shows you what the fillet should look like when you are done either soldering or brazing. Other methods of joining copper pipe is with flares for soft copper and unions for both hard and soft copper. The upper picture is of a flare being made with soft copper. The picture on the lower left is of a union for copper pipe. The picture on the lower right is that of a dielectric union. You would use it when joining a copper pipe to a steel pipe. On most domestic water heaters, steel return and supply lines protruding from the tank are what is connected to your copper water pipes, and that actually creates a problem. When you put two different metals together in the presence of an electrolyte, in this case tap water, you get a reaction called galvanic corrosion. Most tap water contains oxygen, magnesium, fluoride, chlorine, and other suspended particles. These components in the concentration in your water are not bad for you, but they do impart a slight conductivity to the water. Through an electrical process called electrolysis, this conductivity will eventually cause most metal to corrode. To avoid this, you use a special coupling called a dielectric union. It's a coupling that acts as an electrical barrier between the two metals. One side is made of copper, the other steel. Between the two sides there is a non-conducting washer, usually made of rubber, which prevents the metals from interacting. When joining hard-drawn copper pipe and sometimes with soft copper tube, you will use copper fittings. The one difference between ACR and plumbing fittings is a 90-degree fitting. In ACR, we use long sweep 90s. In plumbing and heating, short sweep 90s are mainly used. On the slide, you can see the two different 90s. The picture on the upper left is of a short sweep 90, and the picture on the lower left is of a long sweep 90. The picture next to the 90s shows you the common fittings used. On it are the different types of adapters, elbows, T's, and couplings used in joining copper pipe. I included this sheet in the learning module as a separate download so you can view it better or print it out. On the picture, you will see different letters under the fittings: C, FTG, M, and F. The letter C stands for a fitting end that can be soldered or brazed, and the copper tube will fit into the fitting. FTG is the designation for street fitting ends. What that means is the end of the fitting designated FTG will fit inside of another fitting. M is the designation for a threaded male end. F is the designation for a female threaded end. All fittings are measured by the size of copper pipe you want the fitting to fit on. So if you are ordering fittings for ACR, you would need to specify that you want the fitting for ACR pipe. Remember, ACR pipe is measured by outside dimension, while plumbing and heating pipe is measured by inside dimension. If you look at the far upper right picture, you will see a T. When ordering T's, you must order it in a certain way to ensure you are getting what you want. T's are generally measured from the run to the bull or branch. The run is the left to right, or the length of the T. The bull or branch is the top part of the T. So to order a T like that, you would say I need a copper reducing T that is 3/4 inch C by 3/4 inch C by 1/2 inch C. T's where the run and the bull are not uniform are referred to as reducing T's. If you look at the far lower right picture, you will see another reducing T with all different sizes. When you have a reducing T with different sizes, the way you would order it would be first to say the largest run, followed by the smallest run, followed by the bull or branch size. So the reducing T on the slide would be called a 1 inch C by a 3/4 inch C by a 1/2 inch C reducing T. If you were ordering a T that is uniform in size, say you wanted the run and bull or branch to be 3/4 inch, all you would have to say is I want a 3/4 inch copper T.